Kill the fly. Switch players. Kill the fly. Attacker wins.
This is the fourth phase of the software design project of Team 3, Kill the Fly. First, let's take a look at the main.java file. We create a trace file to store the trace, which is an essential step for multi-threading. We create a path for the sound player, and we create an instance of the simple audio player class. And then we play the soundtrack and give a delay. And we redo these steps to play another sound. And then we create the dispatcher. After creating the dispatcher, we create the proxies. Let's take a look at the proxy.java file. As you can see, the proxies are registered with the dispatcher, and they send the message to the dispatcher. Let's take a look at the dispatcher.java file. In the dispatcher.java, we can see that we have an array list of proxies, and if we go to the run method, we will see that it sends the messages that the proxies want to send, and then it reads from the port in the while loop. If the first bit is equal to 0, it means that the message is sent from the glove. If the first bit is 1, the message is sent from the board. Let's go back to the proxy.java class. We can see that the callback functions of each proxy, if the payload is 0, then the attack failed. So we set the success boolean to false. If the payload is 1, the attack succeeded, and we set the success boolean to true. And let's go back to the main.java file. Here in the while loop, we check that both the booleans are set to true, which means that both of them are a success, which means that the success announcement will be played, and we will return to the end game. However, if that is not the case, we switch the players and ask them to play again. This is the Arduino code for the software design project, Team 3. First, we initialize the serial communication. This is the board file. First, we initialize the serial communication, and then the light sensor is connected to pin A0 on the Arduino. And then, if my serial is available, we read into command, and the dispatcher sends the code word 0 to indicate that the game started. So if the command is equal to 0, the game started, and the attack is initialized to false. Then the program reads the values of the light sensor 30 times in 0.1 seconds increments in a total of 3 seconds. So here it reads from the light sensor. If the value is less than or equal to 4, the light sensor reads dark, then writes this byte to the dispatcher, indicating success. We also have a delay of 0.1 second. Let's take a look at the glove file in the Arduino code. We have the ground pin connected to pin number 18, and the power pin connected to pin number 19, and the X pin from the accelerometer connected to A3. We only used the X axis for this project. If my serial is available, we read from my serial into the command. It checks if the dispatcher sent zeros indicating that the game started. We also have float X to read the initial location of the X pin, and new X to read the new location, and then it calculates the distance, and it is saved into value. If the value is greater than or equal to 50, then we read the my serial. We read the byte from my serial. If the ID is equal to 0 and the payload is 1, indicating that the glove was successful. Else, we also read the byte, and in this case the ID is 0 and the payload is 0, and it indicates that the glove was not successful.